Hello everyone, in this video I will explain about an example of use case of unsupervised learning, clustering. We have the given iris dataset. From the data, we will predict the optimum number of clusters and represent it. This time, we will use k-mean clustering. K-mean is a type of partitioning clustering. That is, it divides the data into k non-overlapping subsets without any cluster internal structure. The objective of k-mean is to form cluster in such a way that similar samples go into a cluster and dissimilar samples fall into different clusters. Conventionally, the distance of samples from each other is used to shape the cluster. So, k-means tries to minimize the intra-cluster distance and maximize the inter-cluster distance. The first thing we do is importing the needed libraries. Then, reading the data. In this part, we can see several rows of the data. After that, to understand the data deeply, we check the basic features. From data info, we know that there are 6 features and 150 data non-null. Then we check the statistics summary. Because there are the features that have an object as a type, we use include all to see the unique, top, and frequency from the data. From this part, we also can see the mean, standard deviation, the minimum data until the maximum data. We can expect that there is no abnormal behavior, there is no negative number, and I think this data is quite good. Then, we check duplicated data. There are no duplicated data and missing value. Then we will determine the value of k. Essentially, determining the number of clusters in dataset or k is a frequent problem in data clustering. In this section, we'll see 2 algorithms that can use for selecting the number of clusters. The first one is elbow method. In this method, we pick a range of candidate values of k, then apply k-means clustering using each of the values of k. Find the average distance of each point in cluster to its centroid and represent it in a plot. Pick the value of k where the average distance falls suddenly. From the graph, we can see that the number of clusters, 3, is where the elbow occurs. So, from the elbow method, we choose the number of clusters is 3. Then, the second one is silhouette method. The silhouette value is a measure of how similar an object is to its own cluster compared to other clusters. The value of the silhouette range between -1 up to 1, where a high value indicates that the object is well matched to its own cluster and poorly matched to neighbor cluster. This time, we pick the range and cluster from 2 up to 5. Then this is the result, and we can see that the highest, the average silhouette score is when the number cluster is 2. Moreover, we can see that the higher the number of the cluster, the lower the average silhouette score. Okay, we see from the bottom. The value of n cluster of 4 and 5 are the bad picks for the given data due to the presence of the cluster with below average silhouette score and due to the disuniform thickness of the silhouette plot. Silhouette analysis is more ambivalent in deciding between n cluster of 2 and 3. The silhouette score for each cluster is above average silhouette score. For the plot with n cluster of 3, the thickness is more uniform than the plot with n cluster of 2, which has one cluster thickness much more than the other one. Thus, we can select the optimal number of cluster is 3. Then the last, we applying k-mean clustering. With using scikit-learn and matplotlib, we can plot and can clearly see the clustering around the data. This is the cluster 1, and the blue is the cluster 2, and the green is the cluster 3. We can also see the centroid from this plot. And that's all about my explanation. And thank you, and I hope you can give me a feedback for a better of me. And see you in the next video.